Question 7. A spherical projectile with momentum q strikes a rigid horizontal plate at an angle phi, measured from the normal. The projectile rebounds with unchanged momentum magnitude, but follows a new trajectory, making the same angle phi with the normal. The duration of impact is delta t. We are asked to determine the magnitude of the average force exerted on the projectile during contact. This problem tests our understanding of impulse and the relationship between force and momentum change. We want to recall some relevant initial ideas. We know that impulse is the change in momentum of an object during a time interval, and that the average force exerted on an object is the impulse divided by the time of contact. When the projectile rebounds elastically, its momentum magnitude stays the same, but its direction changes. Now, let's break down the solution step by step. First, we consider the momentum of the projectile before and after the impact. The initial momentum, P initial, is q at an angle phi to the normal. We can resolve the momentum into x and y components. The x component of momentum is q sine phi, and the y component is q cos phi. After the rebound, the magnitude of the momentum remains the same, but the direction changes. So the final momentum, P final, is still q at an angle phi to the normal. The x component remains q sine phi, and the y component is now minus q cos phi, because the direction has reversed. Next, let's find the change in momentum along the normal direction. The change in the y component of momentum is delta py equals py final minus py initial. Substituting the values, we get delta py equals negative q cos phi minus q cos phi. Simplifying this, we find delta py equals negative 2q cos phi. Now we check the momentum change along the parallel direction. The x component of momentum remains the same, so delta px equals px final minus px initial equals q sine phi minus q sine phi equals 0. Now we can calculate the average force along the normal direction. The average force is given by F average y equals delta py divided by delta t. Substituting the value of delta py, we get F average y equals negative 2q cos phi divided by delta t. Since we are interested in the magnitude of the force, we take the absolute value, F average equals 2q cos phi divided by delta t. This is our final answer. What did we do? We wanted to find the magnitude of the average force exerted on the projectile during contact. We started by calculating the change in momentum along the normal direction. Then we divided this by the contact time to find the average force. Elegant and straightforward. Now let's summarize. The average force is determined from the change in momentum divided by the time of contact. Only the component of momentum perpendicular to the surface changes. The parallel component remains constant,